All right, guys, today we're going to learn how to count. Counting, about time we learn how to do that. Three ways we're going to learn how to count big things. One is called the fundamental counting rule or principle. Permutations is another, and combinations is another. And I've heard rumors that you've heard combinations and permutations a couple of times before, so hopefully this is a good review for you. Key concept. In many probability problems, the big obstacle is finding the total number of outcomes. And this section provides several methods for finding such numbers without directly listing and counting the possibilities, which means it's a quick way to find your total number of outcomes without having to list everything like we did the B, 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 G, 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 B's, all those things the other day. So hopefully this makes it a lot quicker. The fundamental counting rule, or sometimes called fundamental counting principle, for a sequence of two events in which the first event can occur in ways and the second can occur in ways, the events can together occur a total of m times n ways. So basically the fundamental counting rule or principle just says when you have different possibilities, you can just multiply the different possibilities to find out the total number of possibilities. Let me show you one right here. Paula is going to choose the size, color, phrase, and picture for a birthday card for her boyfriend. How sweet. There are 2 sizes, 4 colors, 7 phrases, and 4 pictures for her to choose from. The printing company charges a fee to add extra design elements, of course. She will choose only one of each because she's cheap. How many different card designs are possible? So this is fundamental counting rule. All you do is multiply the choices. So she has 2 choices for the size, and she has, so I said and 4 colors for the color, and 7 phrases to choose from, and 4 pictures to choose from. So all she's going to do is multiply those together, and she would get, let's see, 16 times 2, and she would get 224 different cards with just those options. That's pretty incredible. She should surely be able to find one that she likes out of that many. Notation, the factorial symbol, exclamation point, determines the product of decreasing positive whole numbers. For example, 4, if you see this, it doesn't mean you go 4. It means you go 4 times 3 times 2 times 1, and you get 24. One special definition here, 0 factorial is 1. That is hard to understand, so we're just going to say, okay, that's true. It's a definition. 0 factorial is 1. Okay, let me show an example of this one. In how many ways can I arrange the seating arrangement in the first row of our classroom? Well, it would work like this. The first seat on the far left, I would have 8. There's 9 seats in our front row, so I'd have 9 choices, then 8 for the next seat, then 7 people to choose from, then 6. Do you see what's happening here? Then 5. I would have all these people to choose from. So really, it would be this right here. It'd be 9 factorial. And just for fun, I'm going to punch that in. You're going to be shocked. If we only have 9 people in our class and they all sit in the front row, this is how many different seating arrangements I have to choose from. 362,880. Oh my gosh. That's tons. No wonder I get so confused when I make a new seating chart. Factorial rule, the number of different permutations. There's our big word for the day, one of the 2. Permutations. Order matters, order counts. Permutation means order matters or order counts. Of n different items can be arranged when all n of them are selected. This factorial rule reflects the fact that the first item may be selected in n different ways. The second item may be selected in -1 ways, and so on and so on. That's what we just did. The classroom seating chart that I just did, that was a permutation. It was how many, the order matters. How many different orders of seats on the front row or people sitting on the front row can I make? Those 362,880 of them. That's the factorial rule. That was a permutation. Okay, when all items are different, this is what you do. Permutation rule, 3 parts to it here. The first one, number 1, there are n different items available. They must be different. Like there are 9 different people sitting at my chairs in my classroom. The same person is not sitting 2, thank goodness. Number 2, we're going to select R of the n. We're not putting them back. So once somebody's chosen for the first seat, they're done. They can't be chosen for the second seat, so without replacement. We consider rearrangements like the same amount as be different. For example, ABC is different from CBA because it's a different order. Order matters in permutations. If those are satisfied, the way we're going to figure out is we're going to do this right here. There's a button on your calculator. You go to Math, then you go to Perb. Some calculators say PROB, and then you're going to see this button, NPR. I'm going to show you exactly how to use that tomorrow. StatCrunch probably has it too. I need to play with that a minute to see exactly where that is. But the calculator is so quick, I'm not sure I would use StatCrunch anyway. Okay, now you got to watch this one closely. What if some of the items are identical to the others? This happens the most like when you're trying to figure out how to arrange letters in a word, and some of the letters are in the word more than once. Okay, requirements. Still n items available, but some items are identical. We select all of the n items and not replace them. We consider rearrangements of distinct items to be different sequences. And this is how we're going to do it. We're going to take the total number of whatever the item is and put that on the top. In my denominator, you're going to put the number of the ones that are alike with a factorial symbol in your denominator. So the best way for me to show you this is actually to show you an example. Well, let me put one here. Let's say you got the word Alabama. I don't know why I chose that. Oh my gosh. So what you do on the top, you choose the total number of letters in the word Alabama. It looks like to me there's 7 of them. So you put 7 factorial in the numerator. Denominator, I'm going to put all the letters that repeat. The only thing that repeats in Alabama is the A, and there are 4 of them. And I would punch that straight in my calculator, and that would tell me how many different ways I could arrange the letters in the word Alabama. Combinations rule. This is the other way besides permutations. Requirements. There are n different items available. We're going to select R to the n, same deal. Here's the difference. Number 3 is the big difference. We consider rearrangements the same as above, as if you didn't rearrange them. For example, ABC is the same as CBA, which means order does not matter. Order does not matter. Order does not count. So in a permutation, it's all about the order. In combinations, the order does not matter. So if you meet those requirements, we're going to do this right here. On our calculator, NCR, this is what your calculator is actually performing. N factorial over n minus r factorial times r factorial. But we're going to really depend on our calculator today and tomorrow to kind of get us through there and let it do the work for us. Thank goodness. All right, permutations versus combinations. I've already made a big deal out of this, so this should be a review slide. When different orderings of the same items are to be counted separately, we have a permutation problem. Orderings. But when different orderings are not to be counted separately, we have a combination problem. So permutation, all about order, all about arrangements. Order matters. Combinations, not about order. Order does not matter. An example. I'm going to show you 3 examples here, 4 to finish up this video, and 1 of each thing. A byte is a sequence of 8 numbers, all either 0 or 1, used in computer language. The number of possible bytes then would be 2 to the 8th power, because every single bit, it would be called, you would have 2 choices for. 2 for the first one, 2, 8 times you would have 2 choices, and if you do all those 2's multiplied together, I'm trying, and you would get 256. So that's just a fundamental counting rule right there. A history pop quiz asks students to arrange the following presidents in chronological order: Hayes, Taft, Polk, Taylor, Grant, Pierce. Do you know one of those presidents is from Tennessee? It's this one right here. James K. Polk. Okay, now, if an unprepared student totally guesses, what is the probability of guessing correctly? So we need to know the total, first of all. Now, does order matter? Yes, it's an arrangement. It's asking for the chronological order. So it's a P problem. It's a permutation. They gave 1, 2, 3, 4, 5, 6. So and you're going to arrange all 6 of those. So you could do 6P6 in your calculator. Anytime you're arranging all of them, you could just do this. You could just do 6 factorial. I'm going to punch it in real quick. I want to say that's the 720, but I want to double check and make sure. I lost it right there. 6, and 9 instead. 6 factorial is 720. So the probability of guessing correctly, if somebody's unprepared, you'd have a 1 out of 720 chance of guessing that correctly. Not too good, just saying. You're probably not going to do too well on that quiz if you're not ready. Okay, here's another one where the stuff is repeated. How many ways can the letters in the word Mississippi be arranged? Well, looking at it real quick, there's 11 total letters. Now, they have repeated. There's repetition in there, and order does matter. So it's a permutation, but it's a special one where stuff repeats. There are 4 S's, so I'm going to put a 4 factorial. There are 4 I's, I'm going to put a 4 factorial. There are 2 P's. Now, one thing, we're going to punch this in, but guys, be so careful. Because I have 3 numbers in my denominator, I must put them all in a parentheses. If I don't, your calculator is going to think you're doing 11 divided by 4 and then multiplying by 4 and 2. So don't make sure you do that. I'll punch it in real quick. I got this number right here. I got 34,000. 650 ways. That's crazy. So that may be tomorrow's homework. Bring in all 34,000 ways that you can rearrange the letters in the word Mississippi. What do you think about that? Good homework assignment? I think so. Last one here. In the Pennsylvania Match 6, if I could read, Lotto, winning the jackpot requires you to select 6 different numbers from 1 to 49. The winning numbers can be drawn in any order, so order does not matter, which means I'm doing a C problem. Find the probability of winning if one ticket is purchased. So how many different ways could they do this? There's 49 numbers altogether, and they're going to draw 6 of them. So that's going to be my total number. So I'm going to punch in real quick, 49 C6 on my calculator. Oh my gosh. It gives me this 139838816. So there are 13, almost 14 million ways to draw 6 numbers. That's why not many people win the lotto. So the probability of winning, if you just purchase one ticket, then you have one chance out of 13,983,816 of actually winning the lotto in Pennsylvania. Good luck with that. Got a better chance of being struck by lightning 3 times on your way to buy the ticket than that happening. Maybe not, but at least twice. Anyway, look forward to seeing you tomorrow. We'll work on some of these. I hope this is a review for you. Permutations, combinations, counting. See you then.